condition 7, expansion 5B, and we're looking at number 12. And 12, we have billiard balls. Now, I showed you a shortcut, but I may either go ahead and show you how the shortcut evolves, or probably do that. Go ahead and do the whole problem the way it is, and then explain the shortcut. You'll see how it works out. So this is going to be a two-dimensional, it's a 2D collision. All right, so you have to deal with, there's still conservation of momentum works, but now it's conservation of momentum of the X, conservation of momentum of the Y. So we got a billiard ball moving at 5 meters per second. I guess that's a cue ball at 5, it's 5 meters per second. That's V, call it V1 naught. Strikes a stationary ball the same mass, and we know all billiard balls are the same mass. After the collision, the first ball moves at 4.33 at an angle of 30 degrees, so it's going to glance off this way. And we'll make it, just make it yellow. So it's not really a cue ball, I guess. What's that? Which one's yellow? The 7's the red one, right? No, 3's red. One's yellow. One's yellow. So the 1 ball is hitting the 3 ball. Let's not say cue ball. 1 ball is hitting the 3 ball. And then this guy is going to, we don't know. I gave you a shortcut, but say we don't know what that is. This guy comes off at this angle. And dot, 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 dot. And it told me that this angle is 30 degrees. Assuming a perfectly elastic collision, in order to friction, find the struck ball's velocity. So we're supposed to find what is the V final for this guy. V final block 2. And so here we have V1 final. It didn't tell us that. Looks like we have way too many unknowns here. That's question mark. All right, so if we go down log and we have some angle, we'll be calling that one theta, we'll call this one alpha. So now we got to go through conservation of momentum in the X and the Y. So, 2 screens. So in general we have summation of P I X equals summation of P final X. We have summation of P I Y equals summation of P final Y. So that's our general statement. Then we got to go through and look at it. And so let's go ahead and include the masses. We know the mass and the mass are the same. Let's see what happens to those. So if I go ahead and take initial momentum is mass 1, mass of the 1 ball here.
Mr. Askey,
Yeah.
we do know what V1 final is. It's 4.33 meters per second.
Oh yeah, yeah, you're right. Thank you. 4 point. That's what I was about to say. We may have a little issue here. I figured things might cancel, but thank you. So that's 4.33. So we have M1 V1 naught, just in general. Leave it in general first. Plus 0 because this has no initial velocity. In the X direction, V naught X is equal to, now I can say V1 final times, M1 V1 final. And hey, since the mass is the same, why say M1, M2, right? Why not just say M? If you can do it, do it. We do it, but the two masses, the red and blue, the yellow and the red are the same. So M V1 final X plus M V2 final X. And so now we can see that the M's cancel. We can take the M's out of there. And so this is the same thing then as saying V1 naught X equals V1 final X plus V2 final X. And that's something I'll use. And then on the other one, I know my M's will also cancel in the Y, so I'm going to include those. And so this guy has no momentum in the Y to begin with, so 0. This is the X. For X, this is for Y. So I have 0 equals, and now it's just, since the m's went away, just V1 final y plus V2 final y. All right. So now I got to bring in the sines and cosines. And I'm running out of room. That's bad. Let's go in the blue mode here. And so here, now let's plug in our numbers and our sines and cosines. So I have 5 meters per second equals, this is 4.33 times cosine of 30, because that's cosines for my x. So I really have 2 triangles that are produced here. Okay, I can make a yellow triangle and my red triangle. Okay, and so turns out this is not done correctly, because this should be the same length as this, right? So because these two have to cancel each other. Okay? Now they're going to add in the x. See, because I have no momentum to begin with, I can't have any momentum to end with in the y. So this, I know that's got to be the opposite, and so I know my drawing's wrong. That's a sketch, but that's got to be the opposite. That's going to be the opposite of that. So I probably should have made this guy a lot shorter. Sorry. I don't want to confuse anybody. It's coming in later on. That looks about right. You don't have to do this, but if someone's going to start watching it in the middle of the whole thing, they're going to get confused. Okay, so those two are congruent. Congruent. 2 blues. All right. So that's cosine, but right now we're in the x. So that's this guy, and then now I got to find that one. That's going to be plus V2, which I don't know. V2 final times cosine of, well, I don't know. I showed you the shortcut, but right now I don't know. Cosine of alpha. And then over here, and this is all meters per second. Just keep the units. And then over here on the y, I'm going to have 0 equals 4.33 times sine of 30 plus V2 final times sine of alpha meters per second. So how many unknowns do I have? 2, right? 2 unknowns and 2 equations. So I can go ahead and do all my math, get all my numbers, and then I think what I'll do is I'll pause, do all the number crunching. All right, so now we're back, and I'm just going to show you what I would do. I'd go ahead and get my numbers down as small as I can, get all this as simplified as I can. So we have, okay, we got 4.33 times cosine. Make sure you're in degrees. Student came in this morning very upset. She was in radians. That's why she's getting all the wrong answers. Make sure this is 3.74, right? That's fine. And I'm getting 1.25 up here. Right, I'll do the next one. So I got 1.25. We're going to do that, bring it over, subtract from 5. Get an amen on that. Are we agreeing? 1.25 equals V2 final cosine of alpha. And then on this one down here, make sure I am 40. I see tangent. 45. Yeah, degrees. All right, so now that's just half, right? Sine of 30 is 1/2, so that's going to be 2.14. No, 2.17 here. So just bring that over. It's a negative 2.17. equals V2 final sine of alpha. Correct? Now what I can do is divide both sides. Tell you what, I'm going to write it this way. I'm going to bring this down here, make it easier. 1.25 equals V2 final cosine alpha. Okay, now I'm just going to divide this and divide that. That's legal as long as you're not dividing by 0. So now I get, it's a nice little trick, because my V2s, these now go away. And now I have tangent alpha here. So I end up with 2.17 divided by 1.25 equals 1.73, negative 1.73, 36 equals, you guys can go, tangent of alpha. Okay, now I hope it ends up being, let's say the angle, so alpha then is the inverse tangent of 1 point, I'll say absolute value. Give me the reference angle. Okay, so 1.736. Inverse tangent of 1.736 is bingo, 60 degrees. So I find that alpha is 60 degrees. Once I know alpha is 60 degrees, I can plug that 60 degrees into either one of these equations. I want to plug it in there, I can, or I can plug it into there, and then use that then to solve for what is V2 final. And I'll let you do that. But when you do that, you'll find that V2 final is 2.5 meters per second. You plug that in. So we're going to end up going back to this previous screen then. We just figured out that this guy is going to come off at 2.5 meters per second at 60 degrees. Now I want you to notice something. 30 degrees plus 60 degrees equals 90 degrees. And that's no coincidence, because anytime your masses are the same, we saw that we can get rid of those. And when you do that, you can actually prove this, and if you do it, I'll give you a little bonus. You can prove it that these two alpha. Here's what you find out: that alpha plus theta in this kind of a collision, if the masses are the same, are going to add up to 90, and I should say absolute value of each of those. When you add them both up, you should get 90 degrees, and that's a real nice shortcut on billiard ball type problems. Anytime two shuttles come in, like we do in the hallway when we're doing our little game, you know that as they hit, they're going the angle they're going to make is going to end up equaling 90 if you look at the original direction of motion. So nice shortcut, and that's really, I just answered 12B. So that's how you work that problem. Now you work 13 the same way, only in 13 the extra credit problem, and you work 11 the same way. Only in those, the masses aren't the same, you can't just get rid of them. Now 11 is not bad because there's no angles to begin with, but 13 is kind of, 13's full-fledged, no holds barred, that's why it's extra credit, two-dimensional collision. Okay? And I gave you the answer on 13, so you know you're doing it right. Okay, it's lunchtime.